I'm Paul West. As a chef, I'm passionate about the future of our food. I'll be uncovering the incredible innovation going into growing our favourite foods.
That's all images of one potato.
That's one potato there.
I don't think I've ever examined a potato that closely in my life.
I'm Professor Claire Collins. I'm a dietitian. I'll be at Adelaide University looking at how technology is creating new foods.
Oh yeah, that's nice. That's ready now, I think.
And I'm Dr. Nobby Leong. I'll be using my skills as a chemist to experiment with the taste of things to come.
This is so weird.
Welcome to our second Catalyst special, looking at how we Australians are going to keep ourselves fed in the coming decades.
I reckon we live in a land of plenty. Over 24 hours, the average Australian gets through 3 kilograms of food and drink. As a nation, over a year, that adds up to 572 million loaves of bread, 1.25 billion kilos of potatoes, and a 70 million litre lake of wine. There's one word that describes feeding Australia. Epic. But our food order is going to get bigger. Last year, our population grew by the size of Canberra. By 2050, it's set to tip the scales at 40 million people. Half of Australia is already farmed. New land is at a premium. What we need is some new thinking. To get an idea of the size of the challenge ahead, let's start with some basics. One of our most popular veg.
I'm no stranger to growing the odd spud, but it's always been in my veggie patch at home. And a backyard isn't going to feed a nation. So I'm going to take a look behind the scenes of one of the biggest potato processors in the country. And even standing outside this building is intimidating. The scale here is vast.
Although it feels more like a military base than anything to do with food, this is the Matolo potato sorting plant, and it's the largest in the Southern Hemisphere. It handles 40% of all of Australia's fresh potatoes.
So what kind of volume of potatoes are you dealing with here?
We're doing approximately about 150,000 tonnes a year.
Wow. That's a lot.
That's 937 million potatoes a year, or thereabouts. What once took an army of workers is now sorted by about 65 people.
I hope they're not leaving on our behalf. Okay, good. Oh, smoker, yeah, good.
It's difficult to imagine how they do it, until you see this.
Wow.
This is one way to feed a nation.
What a serious piece of equipment. So what exactly is happening here, Darren? This is enormous.
We grade out any rock, goes through the washing system where it polishes the potato, cleans it up, removes all the dirt. It then travels through hydrocoolers, and those hydrocoolers we're basically cooling down the core temperature of the potato. If the core temperature of the potato remains too high, between 20 and 25 degrees, it just shortens the shelf life. Yeah, increases spoilage.
About 200,000 spuds an hour dance their way through the washer, the coolers and rollers. Every bit of machinery calibrated to be as gentle as possible, because any damage, however small, will be noticed.
And what's this?
So this has got cameras in here, and we're taking photos of the potato as it goes through.
Yep, they photographed the potatoes, every single one of them. It's quality control in minute detail.
So that's all images of one potato.
That's one potato there.
So it's quite thorough.
Yeah.
Very thorough.
And you can see, you're getting different angles of the same potato and side views as well as top view, and obviously underneath as it's going around. And then they control how many blemishes are on that potato and where it's going.
I don't think I've ever examined a potato that closely in my life.
The computer then decides what grade they are and drops them off the travelator onto a packing line. They still get a once-over from a human though. A human like Lorraine.
So things like that brown line on there, that's okay?
No, that's all right, yeah. Because these are a lower grade, yep, and like that's a bit of rot.
Right.
Yeah.
Do you eat many spuds at home?
Yeah,
or are you sick of the sight of them by the end of the day?
Oh, no, I still have spuds.
Yeah, they're a beautiful bit of gear, nice potatoes.
Yeah, I like my potatoes.
Oh, same.
This intense selection is said to be based on what we expect. It seems when it comes to fruit and veg, we value looks perhaps more than we should. But in the future, can we afford to be that choosy? We'll find out what happens to those later.
To me, potato harvesting is getting a fork and bringing it out of the ground and giving them a bit of a wash on the way to the kitchen. This is on another scale entirely. It's almost like something out of a sci-fi movie standing up here.
It's the technology we need to feed Australia right now. But in the future, we can't expect everything to get bigger and bigger. The farmers of the future will have to do things differently. We're going to look at how they might do it, at the new technology coming into the field, and new ways of growing food, based on biology, some of which might be controversial. The farm of the future might be fundamentally different. In the Barossa, Australia's wine-growing heartland, one answer is to ditch the use of chemicals and be more sustainable. Troy Koleski has a degree in enology. That's wine science. He has an interest in the microbiota. That's bacteria and yeasts and how they affect the taste that we all enjoy.
Wine's a bit of a tricky one. Despite what some people say, it's not exactly an essential food source. Everything's in the flavour.
The reason I've come to see Troy is the way he achieves that flavour, how he cultivates his grapes, because he uses no synthetic chemicals, no lab-made fertilisers, herbicides, fungicides or insecticides.
Hello.
Hello.
Hi mate, Paul.
Cool, Troy. Nice to meet you, Paul.
Yeah.
He produces 200,000 litres a year and he's totally organic.
If you want to head up the stairs with me, we'll go to the fermenters and see some action.
Oh, it's a great smell. Oh wow, they're all open.
They are all open. It's a very traditional way to make wine. So what we need to do morning and night is do what's called a pump over. If you want to just grab the end of this hose here, point it into the vat preferably. Pump up. To farm the way we do, it doesn't cost any more than farming conventionally, I guess, with chemicals, and the farm environment is healthier, more sustainable, and the wines, I think, can be better quality.
Even the yeast in the fermenters grows naturally on the vine. Very virtuous. But does it taste any good?
Can I have a taste?
Absolutely, go for it. Very classy.
That is very delicious. If I had any more, I don't think I'd be able to make it down the stairs.
Yeah, that's right. We don't need an accident.
Troy's vineyard offers a glimpse of one way we might grow food in the future, but his chemical-free approach is a risky one. Pesticides in all their forms do help protect a large proportion of our food against all sorts of threats. By choosing not to use them, Troy's left the gate wide open.
Probably one of the major concerns would be biosecurity and getting a pest or a disease that we don't have here, especially in the Barossa or South Australia. We don't have phylloxera, which is a little vine aphid that's rife in Europe and the eastern states of Australia that destroys vines, and you've got to replant the vines on a rootstock. And there's also quite a few bugs, diseases, insects that are, say, in the US or Europe that are not in Australia.
Without insecticides, Troy couldn't put up much of a fight against a phylloxera infestation. And without chemical fungicides, he's vulnerable to another major problem: mildew. The problem Troy faces is how to be chemical-free and not lose the farm. The answer for protecting so many foods has been to use chemicals. 2/3 of Australian crops are grown using pesticides. But can we keep piling it on when the number of resistant pests is growing? It seems we're caught in a loop. As the number of threats grows, so we have to use increasing amounts of chemicals. I'd like to see a way out. Claire's investigating a project that's promising that, but it's not without controversy.
I'm at the Waite campus of the University of Adelaide. It's like a brains trust for our food. They're investigating our food at the molecular level, diving deep into the genetics of our crops. I'm particularly interested in the work they're doing into ways we can farm without chemicals. CSIRO biologist Ian Dry may have one solution: the cure for one of Troy's big threats, vine mildew.
And this one's disease-free.
These are disease-free.
And it starts with a well-known natural process borrowed from bacteria.
Here I have a culture of nature's little genetic engineers. So this is a culture of a soil bacterium called Agrobacterium tumefaciens. And Agrobacterium tumefaciens has the property that it can actually transfer genes from its own cells into a plant cell.
What Ian's team have done is to use nature's genetic engineers to transfer mildew-resistant genes from a wild vine and put them into a cultivated vine. The result is a transgenic vine, seen here on the right, resistant to mildew and produces a premium quality grape with no need to spray.
So piggybacking on what nature would have done.
Exactly.
But this is classified as genetic modification, banned in the state, restricted elsewhere in Australia, with still too many unknowns at this moment in time.
So you could argue, why did we bother to do it?
I was going to ask you that question.
It's a good question. When we first started this work, the industry were very interested in generating resistant versions of the existing premium varieties. The only way we can do that is to use genetic engineering. 10 years, 20 years down the track, the GM debate goes on, and that's why we've also started doing our other breeding work to make sure there is a product that we can put out there.
Ian's transgenic vines have to stay in the lab, and that doesn't help farmers like Troy, trying to grow without chemicals. But Ian and his colleagues are now looking to a new gene technology, one that holds the possibility of ending a century of industrial pesticide use. It may revolutionise crop science. It's called CRISPR-Cas, and molecular biologist Rachel Burton is investigating how to use it.
I think CRISPR is a massive game changer. It's technology that has come out of nowhere in the last few years.
To understand exactly how this new gene technology works, I'm getting a hands-on demo with a handy-sized model of plant DNA.
Building some DNA. Oops.
If we want to make a change in the DNA, we actually have to cut it and remove it or add a piece.
What CRISPR does is effectively edit the genes in a plant.
Okay, so we're going to edit this DNA.
We're going to edit this DNA, and to do that, we're going to use the new mechanism, which is based around CRISPR-Cas.
And it's done with a pair of genetic scissors in the form of an enzyme.
So this is the magic Cas9. This is the enzyme that's going to make the cut.
The enzyme is guided to the right spot by the gene messenger molecule, RNA.
What happens is that the Cas9 recognises the guide RNA and it says, right, I'm going to make a cut in the DNA at this point.
The Cas9 snips the DNA, and usually the cell repairs the DNA perfectly.
So we've got 2 base pairs that have come out now.
But occasionally it makes a mistake in the repair, and the targeted trait, which could be low resistance to mildew, is lost.
You've chopped out that bit.
Yep.
And that's exactly what you wanted to do.
Exactly.
What makes CRISPR different is that conventional GM introduces new genetic material into DNA. But this way of using CRISPR doesn't. It mimics nature's mutations. Rachel's already used it to create barley better suited for brewing, but our farmers will have to wait and see if it's the answer to a chemical-free future.
The Office of the Gene Technology Regulator in Australia is looking at the guidelines. They're trying to decide whether CRISPR is actually acceptable. I think there's a massive potential for CRISPR, and I think that we're going to think of some really smart ways to apply CRISPR. It's all going to be a bit of a juggling act between making sure that the plant's still healthy and making sure that the food it produces is better.
I'm wondering how all this sits with Troy, who's only too aware of the risks.
Thank you.
Cheers.
Cheers, Rolf.
Oh, that's lovely, Troy. What are your thoughts in the involvement of genetic science in the grapes?
Yeah, I mean, I guess, grapevines have been bred for hundreds, if not thousands of years, selective cuttings, I suppose, to improve the overall, genetics. Some have turned out well and some not so. Of course, these days, with all the modern technology, they can cut and shut in the lab and so forth and splice things in and out. But I guess there's all good potential there to continually improve the genetics.
Well, it'll be pretty hard to improve on this one, mate.
Thank you.
Cheers.
Cheers, Rolf.
Spending time with Troy has got me thinking, though. There's a lot of science going into creating disease-resistant plants. But how can we prevent those pests getting in the first place? What can we do to protect our food? As an island nation, the oceans used to do that job for us. We've been really lucky.
Almost nothing that we grow to scale in this country has its origins here. For example, wheat comes from the Middle East, carrots come from Afghanistan, oranges come from India. And the benefit for us was we imported the crop, but we didn't import the pests.
But now we're a global trading nation. What goes out also comes in, and that includes pests and diseases. I want to understand the new science that's helping to protect Australia, and I think the best place to start is with the humble oyster.
G'day, Steve.
G'day, how are you, big fella? Welcome aboard.
So I'm on the Yorke Peninsula in South Australia to meet Steve Bowley.
Do you mind if I tag along today to
No, that's fine. We've got some work to do, so we've got a pair of waders there for you to put on. Come on, mate, see that?
Whip the dacks off?
Oh, you can leave the dacks on, that'll be fine. That'll be
sweet.
fine. So you'll be drying these, and they offer protection for stepping on razor fish and those sort of things.
Steve normally farms around 5 million oysters, but these are not normal times. Australian oysters are under attack from a virus, one that the scientists are battling to defeat. Harmless to humans, it's wiped out populations in New South Wales. It's called Pacific Oyster Mortality Syndrome, or POMS.
Do you get anxious every time you come out, worrying that you're going to find there's some sort of outbreak?
Yep.
Does that ever go away?
No, it doesn't. No, it never does. Yeah. That's the thing with the POMS. It will kill everything within 24 hours. We'll come out here one day, everything will be fine. The next day we come out, everything will be dead. I mean, everything. We better get going.
Okay.
South Australia is on lockdown. Oysters that are coming in are strictly controlled. Fishermen are being told to scrub their boat hulls and not to use wild oysters as bait. Just a few steps taken to stop POMS. If it arrives, they could be looking at 90% mortality.
It's an oyster herpes virus, which host specific, so it only infects the Pacific oyster. It doesn't infect our other farmed oysters. It's an extremely lethal virus. It attacks the connective tissue of oysters, and within a few hours, distressed oysters will start to gape, and following that, they're likely to die within another few hours. Although they're native to Japan, they've been introduced on every inhabited continent, and one of the reasons why Pacific oysters are farmed so readily now in Australia is because of disease that attack other oysters.
The state had been clear of the disease, but only days ago it was found in wild oysters in nearby Port Adelaide. Today, Steve's going to find out if it's reached his farm.
If there was POMS on this lease, you'd be looking at nearly 100% mortality.
Correct. Yep, you certainly would. We better open a couple, Paul. What do you think? Do you like oysters?
I love oysters.
Yeah, same. It's everything that's good about the sea is contained right here in this little baby.
Which is why it's very scary to think that there's a disease out there that could wipe out Australian commercially cultivated oysters.
Yeah, that's right. That's not a bad one. Try that one, big fella.
And how old's this?
Well, it's about a minute old, isn't it? It's still bloody alive when you're swallowing it. There's nothing like having them direct from the water.
Steve's living with the possibility of POMS arriving any day, and you can sense the nervousness about it here. Although there are still places free of disease, like Steve's, it's clear a new longer-term plan is needed. And that he can't do on his own.
It's amazing to think that in our modern age that a foodstuff could almost entirely disappear. I'm interested to see more of the research, but because I've been out here on the lease today, I'm in quarantine. So I'm going to have to send Claire in.
There's a whole range of innovative thinking going into biosecurity, and some of the most important research is happening here, the South Australian Aquatic Services Centre. It offers a glimpse of how we can respond to future biosecurity megashocks like POMS. In the case of the Pacific oyster, it could mean rebooting the whole population. Penny Ezzi is one of the scientists in charge of creating a new breeding stock.
This is about the size of our brood stock. We're not going to be spawning from these ones. They're not part of the breeding program.
They're really massive.
Yeah, so one of these will produce about 50 to 200 million eggs.
Wow.
Oysters are interesting in that they can actually change sex. So a lot of oysters will start out as males and then become females later on in life.
And what would make them do that?
It can be a range of factors. It could be genetics, but there could also be environmental reasons as well.
These particular oysters aren't breeding stock. They don't have proven POMS resistance. The threat from the virus is that it can hang about, lay dormant in winter, and strike again when it's warmer. There's only one real answer: create a whole new generation of resistant oysters.
These are our broodstock, or our adult oysters that we use to spawn our larvae. And at the minute they're in a conditioning system, so they're getting lots of food and slowly warming up the temperature, getting ready to spawn.
All right. And how many larvae do they spawn?
So on average, our female will produce about 50 to 200 million eggs.
Can we go in and see them?
Not at the minute with our biosecurity. These broodstock are very precious.
Okay.
So we're trying to keep everybody out of this room.
All right.
Although POMS has a 90% mortality rate, a small number of oysters are naturally resistant. Scientists have taken those few survivors, bred them together to create a whole new family of young oysters, or spats.
So this is our spat, our third stage of the oyster life cycle.
Yeah. Okay, so this is all the little baby oysters.
It is.
Wow, it just looks like gravel, doesn't it?
These are actually quite large. They're ready to be sent out to the farms.
Yeah.
Just be careful they don't spill in.
Yeah.
So these are about 2 millimetres in size. When they first metamorph, they're about 0.3 of a millimetre in size.
Wow, so they really are quite grown up.
This is gold dust for oyster farmers like Steve. Before POMS, most of the spat came from Tasmania, which was badly hit by the disease.
All of those are going to turn into a fully grown oyster.
Yes.
Although they're producing hundreds of millions of young, it's a fraction of the amount that farmers had access to before POMS. It's going to take several years to repopulate completely. While Penny and her team are thinking about how to manage the present, others are thinking about how to deal with a future POMS outbreak. Professor Jiaju Li has pioneered a process that can keep disease-resistant Pacific larvae on ice until needed.
The techniques we are developing is called cryopreservation. It's pretty much deep freezing the larvae.
Jiaju's groundbreaking process could put whole generations of POMS-resistant oysters into a time capsule for future breeders to access. Today, he's showing Penny a batch that have been in cryogenic sleep for 6 months. Thawing them out is pretty straightforward.
So these larvae has been frozen for 6 months.
Yeah.
And they're still alive and active.
Yeah.
How long can you have the larvae frozen for?
Theoretically, you can freeze as long as you like, pretty much forever.
Our aquaculture is on the front line of biosecurity. So I'm really glad to see how much thought's going into dealing with threats like POMS.
It's been a good day for Steve. A healthy, if small, harvest.
You've got to get the big mouths out because they'll take all the food from the smaller oysters. The purpose of grading is to get all the sizes together. Show us your style. You're a natural.
The local outbreak has been contained. South Australia is POMS free again. I hope it stays that way, but if not, it's good to know we can bounce back. I'm really struck by the innovation and clever science going into protecting our food. But what if I told you there's a way to have more food without doing any extra farming? Maybe a third more. It offers a radically different vision of the way we can feed ourselves in the future. And it doesn't begin out on the farms or even in the labs. It begins in a place like this. The vast Matolo potato sorting plant, where operations manager Darren wants to show me something.
the waistline.
Wow.
So this is quite a high percentage of waste in this load.
Here at Matolo, they're actually quite efficient at keeping waste down. But on average, 20% of potatoes grown in Australia don't reach us. It can be down to shape, size, even appearance. We like our potatoes potato-shaped.
As a layperson, that's an incredible volume to see of wastage. And I mean, obviously, as an operator, that's a volume that you don't like to see.
Yeah, that breaks our heart
to see either. Exactly.
In fact, on average, 25% of all vegetables are discarded at this stage. That means millions of square kilometres of farmland are cultivated to grow food that never reaches us. Not to mention the millions of litres of water used and huge amount of energy that goes into farming. It's a lot to throw away.
And so its final destination,
cattle feed.
And is that something that's then processed for the cattle to eat, or does it just go out as a raw waste product?
Raw waste product just dumped on the ground.
We're really efficient at farming our food, but we're still losing a sizable portion of it in the system, most of which could be put to use.
I find it amazing that 1 in every 5 potatoes that are grown ends up as waste. It's perhaps the future of food's not so much about growing more food, but making more of what we grow.
We might consider it waste, but can science turn it into something we want to eat? As a dietitian, I'm very interested in what we can do with the mountain of food that's simply lost in production.
We're not talking about the food that we waste at home. We're not even talking about the food that gets to the use-by or sell-by date. We're talking about the stuff that doesn't even reach the shops and the markets.
At the Waite campus, food scientists have rethought the problem and come up with some tricks for transforming unwanted food into something tasty.
I was really surprised that ones like this little guy would be rejected.
Well, if you look at this one, it's got a crease along here, and so it's awkward to peel.
John's taken the rejects and turned them into a long-life puree, and from that,
Strawberry
dessert.
Okay.
This is pure potato, so there's no additives, no fillers. It's just 100%
Pure
potato
potato.
with a little bit of water.
the puree has more potassium than bananas, 0 fat, and it's high in dietary fibre.
So it's a frozen dessert, but we're not going to have any dairy in it.
No dairy at all.
So that means for people who can't consume dairy, this is a nice treat that's actually going to be pretty healthy with all this stuff in it.
That's right. Turn that off.
Although the puree process destroys the vitamin C, we're adding in strawberries.
That's actually a pretty high percentage of strawberries.
Strawberries. Well, we want to get a good flavour.
As commendable as this is, I wouldn't want it to lead to creating more ultra-processed foods. The big challenge as I see it is how you turn discarded but edible food into something long-lasting and nutritious.
Oh yeah, that's nice. That's ready now, I think.
That people will actually want to eat. And there's a whole range of these reclaimed foods about to come out. So later I'll be testing a few of them on Paul.
I'm coming at the problem of how to feed Australia from a different angle. This is the last meal that I'm going to have before my diet. It's just so emotional. As an organic chemist, I'm fascinated by the emerging science of taste, particularly how individual tastes determine what we eat. I love strong flavours. Can't get enough of them. Maximum salt, maximum fat, maximum MSG. In fact, I am beginning to wonder if this maxing out is something to do with my taste. If I want to better understand my own sense of taste, I'll need to get it tested. So I've come to the sensory lab at the University of Adelaide. They can establish if I'm among the 1 in 4 of us who have particularly sensitive taste, who are known as super tasters. Sue, very nice to meet you.
Nice to meet
Nobby.
you as well. So we're going to profile you today and your sensory abilities. We've got a couple of exercises for you to do.
What recent science has shown about super tasters is that because they can taste more, it's a bit ominous, they have less of an appetite for many strongly flavoured foods. Lemony. Ooh.
A little bit different.
Glad I'm hungry. Super tasters don't tend to like high-fat, high-sugar foods. And a study of super taster kids showed they were less likely to be overweight. Oh, it's not elegant. That one was barely detectable. And I'm done. Well, not quite.
It's so weird to have that sensation of someone putting an earbud on your tongue.
This will show up bumps on my tongue known as papillae, another indicator of whether I'm a super taster.
Now, look into the camera. Get a good picture.
Moment of truth.
Yes. Nobby, you have no taste. I'm sorry.
No taste?
You are a non-taster.
So I'm not even a regular taster.
No, you're in that smaller percentage of the population
Wow.
that does not pick up
I
these.
can't taste. Okay, moment to digest. What about my papillae?
You have about 10,
The average person?
between the 10 and 50 kind of mark. So about
real-
30.
Yeah, really graphic view of my
Yeah.
tongue here. So as a typical non-taster, my low sensitivity could mean I'm maxing out on flavour just to get a taste sensation. And what's even more interesting is the possibility that non-tasters are drawn to highly flavoured junk foods. It's a lot to think about. I've asked Claire to see if there's a way for me to break free of my cravings and try to reset my tastes.
Hi.
Hey. I'm from Malaysia, so I really love lots of spicy foods. I like a lot of fatty cuts of meat. I love crunchy, salty things like chips, like everybody else does.
I think it's really possible that you're seeking out these super tasty foods as a way of trying to wake up the few taste buds that you have got there. You're in really deep at the moment, is what I think you'd say. I'm going to put Nobby on a diet of simple foods with no stimulating flavours, in other words, bland.
So I quite like cauliflower, so that's good.
Yeah, well, there's not many flavours in cauliflower, so that's great.
Thank you for taking away that positive association with cauliflower. Not much in there.
Next up, let's grab some lettuce. Same again, there's not a lot of the flavourful chemicals in that, but it's a great source of nutrients otherwise. There's good reasoning behind a reset. Loads of discretionary or junk foods are high in taste but low in nutrients. The more we eat them, the more we crave them and their flavours, while they don't deliver the essentials. Now we're going to get you some fruit. It's really interesting, apples and pears on most low allergy types of diets they're allowed because there's not a lot of stimulatory chemicals in there and there's certainly not a lot of flavour chemicals, so they're on your special diet.
If I can enjoy simpler food, I might end up eating healthier. As long as I don't have a whole milkshake, then I'm fine. But can I break the grip my cravings have on my diet? I'll miss you. We'll find out later.
I've witnessed the ways technology and biological science are making a dent in our future food demands as we approach a world population of 9 billion people in 2050. But there's something the farmers of Australia have to face that makes the task even tougher. The climate. Australia is dry. Really dry. Wow. In fact, only Antarctica is a more arid continent. A hell of a place to try and grow anything. And we've always known it.
So somewhere around here is the Goyder Line. It was drawn up in 1865, and it was to break the country into two parts. On one side of the line, there was reliable rainfall, and on the other side of the line, rainfall not so much, and it was more suitable for grazing rather than cropping.
This line drawn in the sand by the then Surveyor General was a guide, mostly for wheat farmers. You can still see traces of those who ignored it. Where the road and the line merge is called World's End.
I've seen lots of signs saying the Goyder Line's around here, but the closest I can find it on a map is this road. And you know you're at World's End when you get out of the car and you're greeted by a tornado of dust. So on one side here, there's country that's clearly being cropped. And then on the other side here, it's just flat grazing country. Looks like there might have been a bit of truth in what old Goyder had to say.
150 years on, we're still battling the same thing, except it appears to be getting worse. In the last 30 years, maximum average temperatures have gone up a degree, while average rainfall on our crops is down 28%. I can't help asking myself, what on earth do you grow when faced with this? On the front line of dealing with Australia's tough conditions are the wheat farmers. I'm in Malala, actually on the wetter side of Goyder's line. Just as it was 150 years ago, wheat is still our biggest crop. Although the kit's changed a bit. I'm with Clinton Tiller and his enormous crop sprayer.
Top screen is that's your guidance, rate controller.
Satellite guided for greater accuracy.
You at least need 12 satellites. To
12 satellites.
12 satellites, and then you've got a base station somewhere that gives you a reference point to get you down to your 2 centimetre accuracy.
So this enormous machine has accuracy to 2 centimetres.
Yeah, so it will steer, and then you go to the paddock.
More accuracy means using less spray. Our farmers are brilliant at making more out of less. In the last 50 years, they've squeezed 2.5 times the harvest out of just 11% more land. But that is beginning to slow. It seems that bigger machines on their own are not going to be enough. Now it's the crops that need to change. While Clinton's family had generations to develop new varieties of wheat, we simply don't have that sort of time.
T-minus 18 seconds and counting engine start.
And so the scientists have brought the lab to the field. Not to harvest wheat, but to harvest data. Part of Clinton's farm is trialling new crops, searching for that tough new variety that will thrive in drought. They'll be analysed using high-resolution cameras that come with super state-of-the-art drones and a team of slightly nervous technicians.
So you've got triple redundancy on that, so ideally we can't...
you can't.
We can't crash it.
Yep. Yep. There's a pilot.
We can't crash it.
Yeah, don't say that.
I said ideally we can't crash it.
Yeah, we're taking off.
The images captured will be used to create a 3D model of the crops over a season. It's so accurate, it can gauge the effect of vehicle tracks on the wheat.
Having these high-resolution images means we can take into account where there's wheel tracks in there, anything that can try and make sure that the performance of the different cultivars is just the performance of the cultivars, just the genetics. We're collecting huge amounts of data, and we've actually got the computing power to be able to deal with that data now.
But it will take a season to gather the data. So Trevor and his team are accelerating the process.
At the Wait campus is the engine room of a new wheat growing revolution. This is the Plant Accelerator, a phenotyping or physical characteristic testing facility.
Wow. What's happening here?
Yeah, so it's a roboticised plant phenotyping platform.
Here, breeders can bring their crops to test them against the worst of the Australian climate, all simulated in a computer-controlled environment. Today, they're doing drought.
So the plant's coming through here. This is our watering station. This will lift the plant up. The computer knows what weight it should be and then can water it to our set weight.
Typical of the cutting-edge approach at Wait, they don't just measure the plant's growth, they look inside it.
The plant comes in, the doors close. So these are the hyperspectral cameras and their light sources.
Hyperspectral images use non-visible light to see beneath the surface.
And as they move, they're scanning.
What this allows Trevor to do is pick up on deficiencies in the plant long before it's fully grown.
We're just looking at the first 2 cell layers, but you can get a lot of information from that. Nitrogen's our biggest fertiliser cost for farmers. If you can have a plant that uses the nitrogen better, you can save costs and reduce environmental pollution.
Here, generations of trial and error by farmers is compacted into weeks of fast-tracked precision trialling.
We can monitor the growth of that plant every day.
So you've really been able to speed up growing the best quality plants across a range of types of soil conditions in
Well,
plant.
ideally, we want a plant that can be drought-stressed or salt-stressed and show no symptoms at all and still grow into a large plant.
Seeing this, it seems to me that growing the food of the future won't just be down to farmers like Clinton. He'll need the support of skilled biologists and data analysts, armed with a range of technologies to extract all we can out of our crops. If you wanted a vision of what sort of technical innovation is needed to feed ourselves in the future, then this surely is it.
That's quite amazing what you're doing.
We like it.
I've set out to reduce my craving for overly tasty food, which I've learned might be connected to my low taste sensitivity. Which really doesn't have any kind of flavour at all. I'm challenging myself to reset my taste. Pasta, And Claire has told me it could be done with diet alone in as little as 2 weeks.
Cold potato, cold eggs,
cold onion, cold cottage cheese to fuel my very cold soul.
So she's put me on a regime of especially bland foods.
Yeah. Ugh.
And for a flavour addict like me, it certainly has been challenging.
Last night I dreamt about eating fried prawns with hummus.
At the end of the fortnight, I was retested.
Well, you've actually improved.
Okay, that's good. A recent study showed that 8 weeks on a low-fat diet can substantially reduce the appetite for fatty foods. So I think there's definitely something in this. Now that I'm finished, it's time to catch up with Claire.
I'd have, a bowl or a plate of chips or something, and they were delicious. But after eating it, I thought, whoa, I actually need something a little bit bland. Maybe that's all in my brain, but the 2 weeks taught me a lot about individual ingredients and individual foods. It was a sort of reacquainting with old friends and what they taste like without salt.
Today, there are so many hyper-palatable foods. Unless people's taste buds are being overstimulated, they don't get those basic tastes.
I knew about the link between pleasure and taste, but I'm really fascinated by this connection with appetite. No one wants to take the enjoyment out of eating.
It tastes so good.
But by understanding our tastes, we might be able to make healthier food choices.
I'm sorry. I'm just going to enjoy this by myself and take a moment.
I think we'll be hearing a lot more in the future about this delicious science.
So good.
In the future, our food choices will have a direct effect on what our farmers produce. I've seen how science is finding ways to grow more food and creating new foods from produce that's rejected. Can waste be tasty?
What's going on here?
Well, I've got a great surprise for you.
Can I look?
Well, not just yet.
I've got some future snacks made from food that could have ended up in the bin.
So first up,
Oh.
Anzacs with a twist.
It's not too bad.
there's in fact no flour in those biscuits at all, but they're actually made from apples. When apples are juiced and the core and the skin and the pulp's all left behind,
this apple pomace is then turned into a powder, a flour substitute.
It's super high in fibre. About 50% of the weight of that is actually dietary fibre.
Great.
Next, a bar snack.
They look like bugs, in a way. They look like a little thing of witchetty grubs.
They do, but see what you think when you taste it.
Is it a carrot? Is it a carrot byproduct, maybe? Oh, it was a carrot.
You were right. You were actually right. It was a carrot. You can taste the spice that's been added onto that one.
They're quite Moorish.
And finally, a dip.
This looks delicious. What is that?
Yes, our reject grade potatoes, the same ones I used to make dessert.
So this is a frozen dessert made out of potatoes.
I never thought I'd be eating potatoes in a cone like this, so that's a pleasant surprise. I'm on a health kick now.
These are just the first steps to a new way of thinking about our food. And it could be a way to get the 9 out of 10 Australians who don't eat enough fruit and veg to make a start.
It's a complex business, keeping ourselves fed, and it's not going to get any simpler. Getting the balance right between growing more and growing sustainably.
Wow, what a view.
Wasting less and protecting what we've already got.
One of the key assets that we have as an island nation is our clean, green reputation, that pristine environment that we have here, and it must be protected at all costs.
We are a fantastic farming nation. Our yields are among the best in the world.
There's not just the farmer working on growing wheat, there's a lot of people in the industry working on wheat and getting it to grow and getting as much grain as we can per drop of rain. Yeah.
We can't just keep the status quo because we've got to improve it even more than we have in the past. So for us, that means we've got to have better varieties and better ways of growing.
But the farmers of the future will have their hands full.
In terms of technology, we are just relearning stuff that maybe people knew about years ago, or we're understanding why nature has it right, I suppose.
We've always relied on the skills of our farmers, but now with an army of cell biologists, geneticists, drone operators, agronomists, molecular scientists, and even software programmers at their disposal, the future is going to be interesting. Hooroo.